Today, Lesson 9C, Angle Relationships and Equations, day number 2. Yesterday, we talked about the idea of employing the fact that we know what vertical angles are and what they represent. Same thing with complementary angles and same thing with supplementary angles. Yesterday, our focus was mainly on problems with vertical angles and supplementary angles, but the idea was we were setting up equations and to find out what x would be so that we would have those types of situations. And today, we're going to add to that picture complementary angles. So, a little bit of background knowledge. Our goal as of several lessons ago is to be able to find missing angles without a protractor. We talked about complementary angles. Typically, that's what a picture looks like for complementary. Remember, the angles don't have to be adjacent, but complementary angles have a sum of 90 degrees. Supplementary angles, typically the picture looks like that. They don't have to be adjacent angles, but most of the time we have situations like this. But supplementary angles are angles that have a sum of 180 degrees. And if they are on a line like that, the supplementary angles, we also refer to that as a linear pair. Also, vertical angles. And vertical angles are formed by intersecting lines. So A and C, angle A and C are vertical. Vertical angles are congruent, or they're equal in measure. So whatever A is, C is the same thing. And same thing with angle B and angle D. So these are the things that we've been talking about the last couple of days. And then 2 lessons ago, we practiced finding missing angles. So in this problem, the measure of angle A is 38 degrees because the 52-degree angle and angle A have to have a sum of 90 degrees because they are complementary. And so we went through lots of problems like this, and that leads us, to what we are talking about today. So here is number 1, and we're going to deal with these the same way that we dealt with them yesterday. The first thing that I want you to do is I want you to write down what type of angles these are. And today in the notes, there's actually those questions. So number 1 says, what type of angles are these? What are they? Complementary. Complementary. Write that down, please. So like yesterday, before you begin, I want you to write down what type of angles you have and what you know about them. What do we know about complementary angles? Just say it. Add up to 90. So that helps us determine what the equation would be. Now, since this is just an extension of what we did yesterday, could I get all of you to quickly turn to your shoulder partner and discuss what equation could we use to solve for x? I'll give you 20 seconds. Go. These are complementary angles, therefore they are supposed to have a sum of 90 degrees. So our equation would look like this. X plus 3 plus 32 equals 90. And once again, the reason why is because this angle and this angle are supposed to add together or have a sum of 90 degrees. And that's where these 2 pieces right here come from. Combine like terms, solve for x, please. So in this problem, the first thing we need to do is to combine like terms. And in this equation, we're going to combine the constants because constants are like terms. Remember, a constant is a number without a variable. And so we have positive 3 and positive 32. That's positive 35. And then, of course, from there, subtract 35 from both sides. We've done thousands of problems like this year. And so x is 55. Remember, x is not 55 degrees. We're not trying to find the degree right now. We're just trying to figure out what x would be to make a complementary angle situation there. All right. So x equals 55. Now, we talked about this yesterday, that we could substitute that back in for x to figure out what that other angle would be, but sometimes there are easier ways to figure that part out right there. So that other angle is 52 degrees. But right now, we're focusing on solving for x. All right, let's go to number 2. Everybody try number 2. All right, so complementary angles, and complementary angles add up to 90, so that helps us with our equation. The 16-degree angle and the 2x plus 7 angle those have to have a sum of 90. So the equation would look like this. 2x plus 7 plus 16 equals 90. From there, we combine the like terms, which are the two constants. That would give us 2x plus 23 equals 90. We subtract 23 from both sides, and I'm trying to squeeze that in there. We've got 2x equals 67. Divide by 2, and x is 33.5. It is not 33.5 degrees. We're just trying to find x. That is not a degree. If you then wanted to figure out what the other angle would be, you would have to substitute that in for x, and that's one way of figuring that out. But for right now, we're focusing on trying to figure out what x would be. And in this case, to make or create complementary angles. Okay, and for whatever reason, this says 37 right here. We just figured out it was 33.5, so pay no attention to that. Okay, so here's what we're going to do. From here on out, it's a review of what we just talked about today with the stuff that we talked about yesterday. So if you look at number 3, that should look familiar. That's something that we talked about yesterday. So we're going to do this in groups of 2 problems now. So please do number 3 and number 4, and then we'll shoulder partner both of those, and then we'll keep going until we finish the lesson. So everybody please do number 3 and number 4. Of course, those ideas from yesterday were the ideas of supplementary angles and also vertical angles. At this point, it should be clear to you that a picture like number 3, that represents supplementary angles. The angles are adjacent and they're right next to each other on the same line. That's what makes them supplementary, or you could think of it as a linear pair. And so based upon that fact, that means they have a sum equal to 180 degrees. So that means our equation should look like this. 2x plus 44 is equal to 180. We subtract 44 from both sides, then divide both sides by 2, and we get x equals 68. Any questions about number 3? And once again, it's not 68 degrees. It's just x equals 68, right, Anmol? Okay. Now, if we wanted to figure out what the other angle is, we could substitute the 68 in for x to figure that out, but of course there probably are easier ways of figuring out what that angle actually is. Number 4 looks like this. This is what we have talked about at the very beginning of the period today. This is a right angle, as you can see in the picture. Therefore, those 2 angles are complementary, and that means that they have to have a sum equal to 90 degrees. So we're going to end up with 4x plus 2x plus 7. The sum of this and this is supposed to be equal to 90. So we would have to combine like terms, and when we do that, we're going to combine these 2 expressions together, and then our 2 constants together, and then from there you solve because you have a regular 2-step equation. Subtract 12 from both sides, then divide both sides by 6, and from there we end up with x equal to 13. And if we wanted to figure out what either of those angles, what they would be, you would substitute those in, but that's not what we're dealing with right now. We're simply trying to figure out what x would be to make the situation that we need. All right, turn your notes over to the back side. Everybody do both number 5 and 6, and we'll do the same thing. We will shoulder partner both of those when we are finished. So I'll give you about 1.5 to 2 minutes to do 5 and 6. And so putting all these pieces together now, vertical angles, complementary angles, supplementary angles. And so number 5, in this situation we have vertical angles, and vertical angles are congruent, which essentially means they are equal in measure. And so our equation should look like this. X plus 9 equals 41. We subtract 9 from both sides, and that gives us x equals 32. And if we substituted it back in, we could easily find the other angle, but I'm not asking you to do that right now. We're just trying to figure out what x is. In number 6, What kind of angles do we see in this picture? Just say it, please.
Supplementary.
Supplementary. What do we know about supplementary angles? They add up or equal 180. So our equation would look like this. 3x plus 2x plus 5. Those two angles are supposed to have a sum of 180. So from there, combine like terms, which gives you 5x plus 5 equals 180. Subtract 5 from both sides. Then divide both sides by 5. And what I saw from almost everybody was x equals 35, which is correct. And of course, like all the other ones, we could substitute it back in if we wanted to find the other, what the actual angles were, but right now I'm not concerned about that. All right, finish it off. Number 7 and number 8, and then we'll shoulder partner both of those. Number 7, we have complementary angles. Complementary angles have a sum of 90 degrees. Therefore, our equation should look like this. 3x plus 5 plus 37. The sum of those two is supposed to be equal to 90. Add your like terms, which happen to be your constants. That would give you 3x plus 42 equals 90. Subtract 42 from both sides and then divide by 3. We've solved thousands of equations like that this year. So x is equal to 16. And once again, there will come a time where I'm going to then have you substitute that in for x so we can figure out what that angle is. But today is not that day. In number 8, we have vertical angles. We know that vertical angles are congruent or are equal in measure. And so therefore our equation should look like this. 4x minus 5 is supposed to be equal to 39. Add 5 to both sides, then divide by 4, and x equals 11. And we are finished for today.